fabrication of a coin cell. And talking about components, we'll be using a case here with gasket. Usually there are other kinds of cases also, including ones with mesh, but here we'll be using the one with gasket. Initially we take the base of the case and on that we place the anode. On top of the anode we are going to place an electrolyte. Here we are going to use electrolytes with carbonate and lithium salts because it's a battery. Usually for a supercapacitor we also use KOH solution.
On top of the electrolyte we place another electrode, which is the cathode side, and on top of the cathode we place a metal spacer, and on top of the metal spacer there is a metal spring that is attached. So the use of the metal spring is that after repeated cycles and like use of the battery, there will be pressure that's created. So to distribute the pressure along sides of the cell, a spring is placed. And now on top of the spring, we again enclose the entire coin cell with a metal case. And the metal case again has a gasket side attached to it.
This coin cell is now pressed using a crimper. It can either be automatic or a manual crimper. This
coin cell fabrication. In this we have this metal case, one with gasket and with other is without gasket. So first of all we have to put one electrode in which is anode side in gasket case. After this we have to put separator, somewhat larger I think. We should remember that separator should be larger than electrodes. Otherwise it will short circuit. Both electrodes will come in contact with each other and they will short the cell. So separator should be larger than both electrodes. Okay. So after this we have to add electrolyte. Electrolyte, it depends. You are making supercapacitor or battery. So for supercapacitor generally you are using 6 molar KOH, and for battery different types of electrodes are there which is based on lithium carbonate salts. Okay. This is for just
should be performed in glove box.
Yes sir. For supercapacitor we can perform outside the glove box. For lithium based salts we have to take care in glove box.
So we are saturating it.
Yes, and depends on separator porosity also sir. How much electrolyte we have to add, because this is GF by D, and whatever in batteries they are using, that is polymer based separator. So it will take more electrolyte compared to that cell grade and those separators. After this we have to add another electrode. After this metal spacer we have to add. And then metal spring. This spring is for, as you see in this, this bulging is there. After some cycling, pressure will create in the inside the battery, and it will means bulge will happen. So same case is happening in a coin cell also. So when pressure is increased inside, that the spring will expand and pressure will be uniformly distributed inside the coin cell. After this we have to metal case, and just we have to check once, and we have to put inside a manual crimper or automatic crimper. So after the so for tightening, and after tightening, after crimping we will get a cell like this. So these are coin cell, and this is stacks. They are making stacks on each other for mobile batteries. These are for like calculators and all the small electronic devices. Different types of geometries are there: cylindrical cells, button cells, coin cells, prismatic cells, pouch cells. Depends on application where we have to use. So for electric vehicles, we are using prismatic cells, LFP based, lithium iron phosphate. And that's it.
Now to summarize, we have demonstrated the fabrication of coin cell before, and the same thing we'll be doing it in a glove box later on, and the same coin cell after crimping will be sent for characterization.
As she has mentioned, the whole setup is done in a glove box. And now to study the battery's performance, we are doing 3 characterization studies. The first one is EIS, which stands for Electrochemical Impedance Spectroscopy. The second one is GCD, which stands for Galvanostatic Charge Discharge. And the third one is cyclic voltammetry. And then after which we also perform some corrosion studies.
In the next video, we'll show these characterization techniques in detail. Thank you.